Our dinosaur of the day is Spinosaurus. Although if you just listened to our interview with Nizar Ibrahim, we did cover a lot about Spinosaurus already. But we'll go deeper in this segment.
There's a lot of history here to get into.
Yes. So yeah, buckle up. It's going to be long. Spinosaurus was a spinosaurid that lived in the Cretaceous in what is now North Africa. And it's one of the largest known carnivorous dinosaurs. It's estimated to be up to 59 feet long, which is about 18 meters, and weigh 20 tons, though new estimates from 2014 and 2018 suggested it could be between 49 and 52 feet long, or 15 to 16 meters, and weighs 6.4 to 7.5 tons.
It's another case of a shrinking dinosaur, which often happens. The estimates get a little more realistic as time goes on.
Mm-hmm. But it is comparable in size to T-Rex, at least lengthwise. Spinosaurus had a long, low, narrow skull similar to a modern crocodile, so it wasn't short and high like other theropods that had large bite forces. Spinosaurus had a narrow snout, and the tip of the top of the snout rounded up a little bit to fit the lower jaw, and you see this in crocodiles. It's so they can grip smaller prey like slippery fish.
It's one of the only dinosaurs that has a bit of an underbite.
Yes. A complete snout from the Chemchem beds estimates the skull length of Spinosaurus of about 69 inches or 175 centimeters, although the skull length by Ibrahim and others was closer to 63 inches or 160 centimeters.
Still large.
Yeah. Spinosaurus had a small crest in front of its eyes. Again, the tip of the snout was expanded, and it had large front teeth. The nostrils were high up in front of the eyes, which is unusual for carnivores because usually the nostrils are in front of the snout. And this nostril placement may be based on how Spinosaurus lived, which was that it was semi-aquatic. Spinosaurus had straight conical teeth that were serrated. However, the teeth could not crush bone. The teeth were narrow and sharp, and the largest teeth stuck out from the tip of the snout and the sides. Spinosaurus had a long, muscular neck that curved in an S shape, and it had large shoulders and large, stocky forelimbs. On its hands, it had 3 fingers each, and there was a large claw on the first digit of each hand.
The other digits had reasonably sized claws as well.
Yeah, just this one was much larger.
Yeah.
The fingers were long, the claws were somewhat recurved, and its hands may have been longer compared to other spinosaurids. Compared to other large theropods, Spinosaurus had a smaller hip bone. Its hind limbs were about 25% of its total body length, and its tibia was longer than its femur.
In general, its legs were shorter than other theropods.
Mm-hmm. The fourth toe, the hallux, touched the ground too, which was unlike other theropods. And its toes had shallow claws with flat bottoms, similar to shorebirds, and that may mean that Spinosaurus's feet were webbed. There is a lot of debate over how much time Spinosaurus spent in the water, and we will get to that. But for now, let's talk about the spines. So Spinosaurus had neural spines on the back that were about 5.4 feet or 1.65 meters long, and they were probably connected by skin, making it sail-like. These neural spines were a little longer front to back at the base. Some scientists, however, think that instead of a sail, the spines were covered in fat and formed a hump. If it was a sail, though, there'd be a membrane of skin and thin tissue. In 2014, Ibrahim and others suggested that the spines were covered by skin, like a crested chameleon, and due to compactness and sharp edges, it probably had poor blood flow. Spinosaurus' neural spines are much larger than the neural spines of other spinosaurids. The sail on its back may have been for thermoregulation or display, so to attract mates or intimidate rivals or make it look larger. If it was for thermoregulation, it had a lot of blood vessels, so they could have used the large surface area to absorb heat so that it would not overheat. Spinosaurus was so large that it had effects of gigantothermy.
So basically, it was so big that when it produced heat from moving around or digesting food or something, that its body tissue, even if it wasn't blubber or something intended to keep heat in, all that extra mass around it would keep heat in, so it might have been in danger of overheating, and thus the help of having a sail for reducing that.
Yes. The sail also may have helped it warm its blood enough to counter the cold waters that Spinosaurus spent its time in.
Oh, that's a fun idea.
Mm-hmm.
And of course, it could be for both display and thermoregulation. Doesn't necessarily have to be either or.
So Spinosaurus spent time in river systems in North Africa in the Cretaceous, so what is now North Africa. This may mean that Spinosaurus lived in climates where the night temperatures were cool and then in the day it wasn't too cloudy. So it's possible that the sail radiated excess heat from the body instead of collecting it, and that would have cooled it down. Bailey thought that the sail could have absorbed more heat than it radiated and suggested that Spinosaurus and other dinosaurs with long neural spines had fatty humps to store energy or insulate or shield them from the heat. If Spinosaurus neural spines were for display, Ernst Stromer, who named Spinosaurus, thought that the size of the neural spines may have been for sexual dimorphism.
In other words, the males may have had a huge sail to impress females.
Yes.
But the females might not have had them, or had smaller ones.
Stromer did compare Spinosaurus neural spines to bison and some chameleons and other lizards. Bison had spines covered in muscle and fat. They form a hump. But he also thought it was unlikely for a predator and thought Spinosaurus probably had a sail. Spinosaurus was mounted in the Paleontological Museum in Munich, more on the was later, and it had a short, very arced sail. And then in 1936, Stromer rearranged the vertebrae to be longer, and then the sail had a more gentle slope. Jack Bailey in 1997 supported this buffalo back hypothesis of the spines and suggested that Spinosaurus, Ouranosaurus, and other dinosaurs with long neural spines had shorter, thicker neural spines to those found in animals with sails, and that the neural spines were similar to humpbacked mammals, such as bison. So if it was a hump, it could store energy, or it may have stored fat during seasons when fish swam upstream to spawn so it could get by the rest of the year with less food. And Spinosaurus may have had to travel to search for fish for long periods.
The camel dinosaur.
Yeah. The hump could also have been for display if it was a hump. The fat hump shows that it was well fed and a successful predator, and then more likely would have been chosen to be a mate. But anyway, back to the sail idea, because that is more widely accepted. Gimsa and others in 2015 suggested that the Spinosaurus sail was like the dorsal fins of sailfish, and they were for hydrodynamics. They said that the dorsal neural spines formed a roughly rectangular shape, similar to sailfish, and so it may have used its long, narrow tail to stun prey like a thresher shark. And I should say, the way we viewed Spinosaurus' tail in 2015 is different from how we see it now.
Oh, yeah.
Sailfish herd schools of fish into a bait ball, and they trap the fish so they can snatch them with their bills, and they use as a screen to encircle the prey. The dorsal sail would have helped Spinosaurus with moving sideways, the neck and tail, like sailfish and thresher sharks.
And we discussed this similarity, or really lack of similarity, between Spinosaurus and sailfish and their respective sails in the extended version of our interview, which is available to all of our patrons. So if you're interested in hearing more about the comparison between sailfish and Spinosaurus, definitely check out the extended version of our interview with Nizar in our premium content feed on Patreon.
Yes. Spinosaurus had short legs for its body. Originally, Spinosaurus was thought to be bipedal. Now, I think it's thought to be quadrupedal, at least facultative, so if it needed to be, it could. It may have crouched in a quadruped posture. Ibrahim and others in 2014 found that the hind limbs of Spinosaurus were shorter than thought, and the center of mass was in the midpoint of the trunk region, not near the hip, like in bipedal theropods. So they thought that Spinosaurus was poorly adapted for walking on land and would have been quadrupedal on land. Its pelvis was also smaller than previously thought, which meant less space for large leg muscles. In 2018, Henderson found that Spinosaurus was probably fine walking on two legs on land, and its center of mass was close to the hips, and that it could be bipedal. So there's a lot of debates over pretty much every aspect of Spinosaurus. Spinosaurus had a long, narrow tail with its own tall, thin neural spines and long chevrons, so that made a flexible fin or paddle-like structure. Scientists used to think that the sail on the back extended to the sail on the tail. But as of this year, 2020, Ibrahim and others found that the tail was deep and narrow with a paddle or fin-like shape, like newts and crocodilians. The 2020 paper about the tail, which we did cover in an earlier episode, Garrett did as part of the news, it describes neural spines and deep chevrons on the tail, which had a broad paddle shape. Let's start with the thin spines on the tail. They were thin compared to the back. The back spines are broad. The tail spines are thin in all directions and they're long. They're about a third the length of the spines on the back. So there's not a smooth transition between the tail spines and the back spines. The shortest spines are just behind the hips. The tail is asymmetric as well. The top has long, thin spines, and the bottom has deep chevrons. So on the bottom, it's this flexible, ordinary-looking tail, but then on the top, it's tall and thin, and the tail vertebrae overlap less. The tail was flexible, and it could move side to side, so it wasn't a stiff tail, and that would have helped Spinosaurus propel itself through the water. This broader, bulkier tail may mean that the center of mass of Spinosaurus was shifted back, and bipedal walking would have been a little bit easier. The model shows the center of mass in front of the hips, but close enough to still be bipedal. The 2014 study by Ibrahim and others found Spinosaurus had dense bones, which is common in animals that swim a lot because greater bone density helps with buoyancy so it can swim under the surface. They also found the feet to be flat-bottomed. So originally, Spinosaurus was thought to be bipedal and have a tripod posture and a hump. From the 1990s to 2014, Spinosaurus was thought to be this long, lightly built theropod. So we moved a little away from this tripod posture with a sail or a hump on its back.
And sometimes in that period, it's depicted with a more round sail on its back, sort of the Jurassic Park 3 model.
Mm-hmm.
It's a good time capsule of that time period.
Yeah. The 2014 model changed things, though, and that's when it showed it with this crocodile-like skull and the sail on the back and as an obligate quadruped. But the accuracy of the 2014 model has been questioned because it's a composite of different Spinosaurus individuals and other Spinosaurids. John Hutchinson warned that could result in it being inaccurate. Scott Hartman thought that the legs and the pelvis were too short. Mark Witten agreed with the proportions in the paper, however, after talking to Ibrahim and Simone. There's also been debate on the size of the hind legs of Spinosaurus. Baryonyx and Suchomimus are thought to have hind legs like other theropods, but reconstructions are based on subadults and juveniles, so it's possible that their hind legs shrank proportionally as they matured. It's possible that Spinosaurus was more advanced and specialized than other Spinosaurids. So, to recap, Spinosaurus had dense limb bones, long forelimbs, flat feet, tiny nostrils high on its snout, short legs, large claws on its hands, elongated jaws, and conical teeth. The flat feet would help it walk over soupy substrate so it wouldn't get stuck. Possibly they were webbed. And it also had a sensitive snout so it could hone in on prey underwater. And it had a flexible tail that could propel it through water. So based on all of these characteristics, Spinosaurus probably spent most of its time in the water.
The big debate is how deep was it in the water at this point?
Yes.
How semi-aquatic versus aquatic was it?
Yes. And as of the latest paper in 2020, there's still a lot of debate over Spinosaurus. Mark Witten said, quote, "Our science on this unusual dinosaur is in its infancy and forming robust ideas about its swimming pose and capability is going to take time," end quote. In 2018, Donald Henderson suggested that Spinosaurus was not semi-aquatic. He created 3D models of Spinosaurus and other dinosaurs to test the centers of mass, buoyancy, and equilibrium of animals in freshwater, so Baryonyx, T-Rex, Allosaurus, Struthiomimus, and Coelophysis. He studied the buoyancy in the lungs of crocodilians as well, and then compared it to Spinosaurus's lung placement, and found that Spinosaurus couldn't sink or dive below the water surface, and it also would have been able to keep its head above the water surface while floating like other non-aquatic theropods.
Yeah, so it would have had to exhale most of its air in order to dive, which is still possible, but it would have had to exhale more than crocodilians do, which he thought was unlikely, so maybe it just wasn't in the water.
He also found that Spinosaurus had to paddle its hind legs to keep it from tipping over to the side, which modern semi-aquatic animals don't need to do. And he modeled this and tested the model with alligator mississippiensis and emperor penguins. So he found that Spinosaurus could float with its head above water, and other dinosaurs had similar results. This is compared to alligators, which returned to their original topside position when they were tipped to the side. Basically, semi-aquatic animals can self-right themselves. But the Spinosaurus model rolled over to the side when it was tipped, so maybe it would have easily tipped over and then would have had to use its limbs to stay upright in the water. So Henderson then suggested that Spinosaurus probably didn't compete to hunt in water, but would have spent time on land or in shallow water. But again, that was in 2018.
And we're expecting an updated Spinosaurus model to come out any day now.
True. Ibrahim, Pierce, Lauder, and Serino and others in 2018 studied Spinosaurus' tail and found that it was keeled and well adapted to propelling it through water. They found that the elongated neural spines and chevrons meant it could swim in a similar way to modern crocodiles, so it could have been in the water for long periods of time to hunt. A juvenile specimen found in 1999, described by Simone Maganuco and Cristiano Del Sasso, found that it developed semi-aquatic adaptations at a young age or maybe even at birth. And that specimen was about 5.8 feet or 1.78 meters long. So, going back to the tail could probably have helped it with propelling underwater like modern crocodiles, but not all scientists agree on this. Some think that the thin bones at the end of the tail made it not as flexible as a crocodile's. Others think that it being a stiff paddle underwater could make sense, but that Spinosaurus wasn't necessarily a predator that pursued prey often, and there could be other reasons for its weird tail. In 2016, Vullo, Allen, and Cavan suggested Spinosaurs would be able to adapt in the water like eels, and that's based on convergence in the shapes of jaws and teeth in Spinosaurus and pike conger eels, but they didn't say anything about Spinosaurus being semi-aquatic. Spinosaurus probably lived in something similar to the mangrove swamps of today's Florida Everglades. That's based on roots found growing from the lagoonal muds in marine sands, and that only happens in mangrove swamps. So mangroves, that means there's seawater that's calm, the temperatures are warm, and there's low energy shorelines. So Spinosaurus lived in a humid environment with mudflats and the mangrove forests. And it was also an area covered with sprawling lakes, rivers, and deltas. It's possible Spinosaurus only came onto land to lay eggs or moved to a different river and then spent the rest of its time in water. Other dinosaurs that lived at the same time and place as Spinosaurus were titanosaurs like Paralititan and Egyptosaurus, and other animals included fish, crocodilomorphs, lizards, turtles, pterosaurs, and plesiosaurs. Fish found in the same fossil formations include lungfish, giant coelacanths, and large sawfish. Spinosaurus probably ate fish. So Charig and Milner suggested that Baryonyx, another spinosaurid, ate fish, based on being similar to crocodilians. Baryonyx has also been found with fish scales and juvenile iguanodon bones in its stomach. A spinosaur tooth and a pterosaur bone in South America suggests that spinosaurs also preyed on pterosaurs, maybe during dry seasons.
Or at least scavenged them.
Right. Spinosaurus was probably a general and opportunistic predator, but it may have been biased to fishing. So that would mean it probably scavenged and then ate a lot of small or medium-sized prey, and it never would have given up an easy meal. In 2009, Del Sasso and others looked at foramina, small passages that lead to the same cavity in the snout, and found probably pressure-sensitive receptors that could tell motions of fish when they swam through water, so it would have created pressure waves. So Spinosaurus could know when fish were around and when it was best to attack them.
Without even looking.
Yeah.
Just sensing them through the big nose.
Yes. In 2013, Andrew Cuff and Emily Rayfield found via biomechanical data that Spinosaurus was not an obligate piscivore, so it didn't have to eat fish, and that its diet changed as it grew up. Spinosaurus jaws were not adapted well to resist lateral bending compared to baryonyx and modern alligators, so probably ate fish more than land animals. In 2010, Romain Amiot and others did an isotope analysis and found that oxygen isotope ratios of spinosaurid teeth, including of Spinosauruses, had a semi-aquatic lifestyle. The ratios were closer to those of turtles and crocodilians, so it may have switched between terrestrial and aquatic habitats to compete for food with large crocodilians and other large theropods. But these oxygen isotopes showed exposure to aquatic environments for long periods of time. Spinosaurus' teeth were more widely spaced apart than other theropods, and its teeth interlock like a fish trap. They were good for puncturing and tearing. It could grab its prey and then yank its head violently up and down, ripping out chunks, according to Hans-Dieter Seuss.
If you've ever seen a crocodilian, like a Nile crocodile, do this move, you know what we're talking about.
Mm-hmm. So Spinosaurus may have been specialized to hunt for fish at the edge of rivers or to swim and hunt. The higher nostrils mean that it could breathe while its snout was in the water, but it probably didn't have a good sense of smell. It also wouldn't have needed it when going after fish. The type species of Spinosaurus is Spinosaurus aegypticus or Spinosaurus aegyptiacus. And now we get to the crazy history part. So Spinosaurus was first discovered in Egypt in 1912 and then described by Ernst Stromer in 1915. The genus name means spine lizard, and Spinosaurus aegypticus means Egyptian spine lizard. There's a potential second species, also a long story, Spinosaurus moroccanus, and that means Moroccan spine lizard. Some scientists also think Sigilomosaurus is a synonym of Spinosaurus, but not everyone agrees. The holotype of Spinosaurus included ribs, gastralia, vertebrae, teeth, dentaries, left maxilla, and neural spines. So again, starting at the beginning with Ernst Stromer. Stromer went to the Bahariya Oasis in Egypt in 1911. That wasn't his first visit to Egypt, however. His first expedition in Egypt was in 1901. So what happened was George Schweinfurth founded the Royal Geographical Society of Egypt in the late 1800s, and he was an archaeologist, geologist, and botanist who discovered mammals and other fossils, and that led Stromer to his first expedition there. Some background on Egypt, because it impacted the history on Spinosaurus. Egypt was in a lot of debt, and in 1876 formally declared bankruptcy. A few years later, there was a nationalist uprising, and Britain stepped in, and Britain and France ruled as its creditors. Then Britain ruled Egypt as a protectorate, and they solemnized this in the arrangement in the 1904 Entente Cordiale. France got Morocco, and then Egypt went to Britain. So Stromer had to get his permits from the British authorities to dig. On November 7th in 1910, Stromer landed in the port of Alexandria, Egypt, but then he had to be in quarantine for 2 days because somebody on board was suspected to have cholera. So the cargo was unloaded, but the passengers were still on board. Ernst Stromer was a baron, a gentleman, from Nuremberg in Bavaria. He was also an associate professor at the University of Munich, and he was 40 years old in 1910. At the time, he was accompanied by scientist Dr. Lukes, who brought his wife. Stromer was not married yet, and he thought that the journey was too difficult with a wife, so he didn't like his companions that much. They didn't get along. On November 9th, they all got off the boat, and then on November 10th, they took a train to Cairo. At the time, German geologist Karl Alfred von Zittel was a mentor and thesis advisor to Stromer. He published the Rolfs Expedition, which produced a reliable but incomplete geological map of the Western Desert, which did help Stromer. In Cairo, Stromer went to George Steindorf's office, a German Egyptologist, as a courtesy call and to help plan his expedition. Steindorf in 1901 had visited several oases of the Western Desert, including Bahariya. On November 15th, Stromer was still missing Richard Markgraf, a man from Austria who lived in the desert now and collected fossils commercially and sold them to paleontologists and museums, mostly in Europe. Markgraf and Stromer had met in the winter of 1901 and 1902, and Markgraf was Stromer's fossil collector, Samler, for a decade and a half, as well as a friend. Markgraf was an itinerant musician that, at the time, he was also ill and penniless. So that's how he ended up setting up as a commercial collector of fossils and other natural collectibles in Egypt. Before World War I, Markgraf is the one who managed to ship fossils to Munich for Stromer to prepare and study, but they ended up being badly damaged and didn't get to Munich until well after the war. Markgraf kept collecting for Stromer during World War I, between 1911 and 1914, but the conflict severed their contacts, and Markgraf ended up dying in 1916. So at this point in 1910, Markgraf was often sick. Could have been malaria or intestinal bleeding from typhoid or chronic amoebic dysentery. So Stromer was worried about him and the fact that he couldn't find him in November of 1910. Stromer also got in an argument with Dr. Lukes and then offered to provide him with half the expedition's water containers and supplies so that he could go on his own journey and be rid of each other. There was tension between Germany and Britain at the time, so it took a while for Stromer to get his permits to go into the desert. He finally left on his expedition November 18th, and at that point, he had reunited with Markgraf. Stromer at the time was looking for early mammals in North Africa, like early whales and sea cows and land mammals. He thought that mammals, including humans, originated in Africa, not Europe, which went against the popular thought at the time. Stromer, luckily for us, kept very detailed journals. In December of 1910, he met his then future wife, but he didn't marry her until 1920. They had 3 sons together. And then he went back to Cairo on December 21st. Markgraf was ill again and couldn't go with Stromer to Bahariya Oasis, but Stromer didn't speak much Arabic. so he still needed help. The budget for his 1910-11 expedition was 18,000 German marks, and that included shipping. Stromer came from an aristocratic family but was not that wealthy. Stromer needed a replacement for Markgraf, so someone recommended a gentleman Hartmann. It took Stromer 2 days to locate him, but he didn't get along. So he didn't get along with a lot of people on this trip. Anyway, he found a dragoman, a guide and translator, Mr. Mohammed Hazranin El Hitu. It took Stromer a while to secure permits from the British, French, and Egyptian authorities to travel to the Western Desert. Then New Year's Eve of 1910, he took a train to Medinet El Fayum. And that's where he met Mr. Mohammed, who had actually worked with him in earlier expeditions, but as a servant. So he hired him for the trip, but he didn't trust him. He was a bit of a colonialist snob, and he didn't like that Mr. Mohammed was trying to rise, quote unquote, above his station.
Yikes.
Yeah. However, Stromer made it deep into the desert by noon the next day. So January 11th, he was in Bahari Oasis and he found dinosaurs.
So this is now 2 months after he got there? He got there in November, you said?
Mm-hmm. It was a long trip. He had his base of operations in the Bahari Oasis, but there was a sandstorm, so he explored, but he couldn't find too much. Then, on January 14th, 1911, he found 3 large bones, so he cut up mosquito netting and soaked them in a flour and water paste to cover the 2 larger bones. This actually might have been maybe January 18th instead of the 14th. There's conflicting sources, but he wrote in his journal he found, quote, 3 large bones which I attempt to excavate and photograph. And then later he found more bones, including a gigantic claw. He wrote in his journal, quote, apparently these are the first of Egypt's dinosaurs, and I have finally before me the layer that contains land animals, end quote. So he went there looking for mammals, and he found dinosaurs. But logistically, it wasn't clear how to preserve and collect these fossils. The desert's really destructive for exposed fossils. In February, they packed up specimens in 8 wooden crates with the help of Markgraf, who had recovered by this time, and then arranged to ship them to Munich. And then Ernst Stromer was in Munich at home by February 23rd. Markgraf kept excavating fossils in the winters of 1912 and 1913, and he ended up finding a partial, what would be named Spinosaurus skeleton in 1912 in the Bahari Formation in western Egypt. On Stromer's instructions, Markgraf finally closed excavations in April of 1914 and then returned to Cairo to ship his fossils to Munich. That was about 1 month before World War I. So Markgraf had a hard time getting Anglo-Egyptian authorities to cooperate. They did not trust him and Stromer because Stromer was German. Markgraf, unfortunately, would only get paid once his fossils were delivered successfully to Munich. After the war broke out, Stromer wrote to British and Egyptian authorities begging for his fossils, but it didn't work. And then Markgraf died, and his wife was desperate, so she wrote to Stromer. Stromer appealed to his British friends at the Geological Survey of Egypt, and they paid Markgraf's widow a fee and then took the 12 cases of fossil material for safekeeping. And then eventually Stromer got the fossils in 1922.
So about a decade after they got out of the ground?
Yes. But that didn't stop Stromer from publishing, so meanwhile he wrote monographs on the geology of the Bahari Oasis and then pieced together fossils that Markgraf had shipped in 1912. In 1915, he officially named Spinosaurus aegypticus. In World War I, Stromer served as a male nurse. He had medical training, and then he became a military geologist at the Geological Survey in Strasbourg, which was German territory, and his geological skills were valuable to tactical planners.
I never thought of that. When you're digging lots of trenches, geologists are useful.
Yeah, that's true. So Stromer returned to Munich November 1st, 1919, and got an appointment to the Bavarian State Collection of Paleontology and Historical Geology. After the war, however, there were food shortages in Munich and food riots and violence, so Stromer went home to Nuremberg. In the winter of 1919 to 1920, he taught at the city's commercial college and retreated to his family's nearby castle and estate that had food because of the lands and farm. In October of 1920, he was back in Munich with his wife, Elisabeth Rennenbaum, and then promoted to chief conservator of the Bavarian State Collection of Paleontology and Historical Geology, and then 9 months later made an honorary professor of paleontology at the University of Munich. So July 23, 1921, he became a full member of the Bavarian Academy of Sciences. He worked with international scientists to get his fossils from Egypt, but because of inflation, Stromer couldn't afford to ship them. So a former pupil of his, Bernhard Payer, paid Cairo officials to have the crate shipped, and they arrived in the summer of 1922. But the fossils were, as Stromer later said, quote, badly smashed up. In Cairo, the staff at the Museum of the Geological Survey had unpacked and examined the fossils and then done a poor job repacking them. Stromer knew he probably wouldn't go back to Egypt. Markgraf was dead at this point, and Stromer was poor because of Germany's conditions after the war. In 1936, he provided a reconstruction of Spinosaurus with a sail and a skull similar to a megalosaur or allosaur, though he knew it had a peculiar lower jaw. Stromer compared this specimen to a crested chameleon because of the neural spines or sails. He gave Spinosaurus a more than 8-foot sail, an elongate trunk, massive forelimbs, a long neck, and a long skull, and showed that it may have been quadrupedal on land. But Spinosaurus led to what's known as Stromer's riddle. Where it was found, there were multiple carnivores in the area, yet the carnivores didn't seem to compete for prey, so the riddle was, how was this possible? And it wasn't until many years later that we figured it out. So Spinosaurus was mounted at the wall at the Paleontological Museum in Munich, and then the Nazis came to power, and Stromer openly resisted the Nazi regime. However, he was an aristocrat, so that protected him. In 1930, Stromer was head of the paleontology section of the Bavarian State Collection of Paleontology and Historical Geology, but his career stalled because he didn't join the Nazi Party and he spoke out against Nazis, and he also kept close relationships with Jewish friends and associates.
That's a nice legacy.
Yeah. There were many paleontologists who were relieved to find this out. July 7th of 1937, Stromer was 65 years old and then forced to retire from the university and the state collection. He stayed in Munich and remained a fellow of the Bavarian Academy of Sciences, and he kept doing research and publishing papers. The Nazis, during that time, made sure that every institution in Germany was headed by loyal party members, which is why they made him retire. This meant that the director of the Bavarian State Collection post went to Karl Berlin in 1940, after Stromer's friend Ferdinand Brauley reached his mandatory retirement age, and Berlin was an ardent Nazi. Stromer kept demanding Berlin to remove the Bavarian State Collection from the museum and put it into a protected location far from Munich. But Berlin kept dismissing him. He didn't think that Munich or Germany would be attacked, and that's based on Luftwaffe chief Hermann Göring. Even when the fine art and science museums throughout Germany removed collections to caves and salt mines, Berlin didn't change his mind. Brauley, who was still an emeritus at the museum, quietly removed small specimens from the museum in his briefcase. And he stored them in Princess Theresa zu Ottingen-Spielberg's castle, who was an ally. She was a paleontologist and noblewoman, but he couldn't transfer a lot of the collection, especially any bigger pieces. So Stromer kept demanding, but Berlin threatened Stromer at least twice that he would move him to a concentration camp. Berlin reported Stromer to Nazi authorities, but they didn't take direct action. What happened was Stromer had 3 sons, Ullmann, who was born in 1921, Wolfgang, born in 1922, and Gerhard, born in 1927. Ullmann and Wolfgang were sent to the Russian front as soon as they were conscripted, and Ullmann was killed November 10th of 1941. Wolfgang survived until November of 1944 and then disappeared somewhere into Russia. Stromer and his wife by then had retreated to Grunsberg. And April 24th, 1944, Stromer learned of the Royal Air Force bombing in Munich that destroyed his life's work, including the Spinosaurus holotype.
It's a terrible few years for him.
Yes.
And a lot of Europeans, I suppose.
Yes. On April 25th of 1945, Gerhard died within months of being assigned to a battalion fighting Allied forces in northern Germany. And then less than 2 weeks after his death, Germany surrendered. The Royal Air Force bombing of Munich, of course, that happened. It ended at 1:40 a.m. on April 25th. More than 200 Lancasters dropped hundreds of bombs, and more than 7,000 buildings near the train station were in flames. The museum was on fire, the collection was destroyed, and of course, again, that includes Stromer's Spinosaurus. However, there are still detailed drawings and descriptions. After World War II, paleontologists were more conscientious about making casts of fossils in case the originals were destroyed because of this. So Stromer, again, he had moved to his family's land, so he was not in Munich at the time. He still wrote and published scientific monographs into his late 60s. And then, May 5th of 1950, Wolfgang, his son, who was referred to as missing at the Russian front during the war, returned. He was a physicist, and the Russians apparently kept pressuring him to produce poison gas after they captured him. He refused, and then he was put in multiple prison camps in Siberia for years. Stromer was 80 years old when Wolfgang came home, and he lived long enough to learn that his son and his wife, who he married shortly after, would have a daughter. So at least there's that. I think there was some things I read where he seemed to be holding out until his son came home.
That's nice.
He died at age 82, December 18th of 1952. So, after that, not much was known about Spinosaurus for many years. There were Spinosaurid remains that were first identified as Spinosaurids in Tunisia from the Lower Cretaceous in 1988. They were found in 1912 by Pervinkier, but they were thought to be reptile fossils. And then in 1951, LeParent thought that they were dinosaurs. And then the 80s, we knew they were Spinosaurid. The teeth are different. It was thought to be other reptiles, and briefly in 1978 thought to be plesiosaur teeth.
They do have a certain aquatic nature about them.
It's true. In 1987, drawings of the Spinosaurus holotype were compared to Baryonyx, which had a crocodile-like skull. And then in 1998, Suchomimus was described and named from Niger, and it had tall neural spines. And then an international expedition in the Sahara Desert in 1995 found more Spinosaurus fossils in the Kemkem region, including isolated teeth and fused nasals. And the Kemkem region is in Morocco and Algeria. Dentary fragments, cervical vertebra, and a dorsal neural arch found in the northern part of the Kemkem region led to Dale Russell naming Spinosaurus moroccanus in 1996. And Russell and Torkett described a partial snout in 1998, but again, the validity of Spinosaurus moroccanus is debated. There was other Spinosaurus material in 2003. Milner described an incomplete snout and left dentary that was at the Natural History Museum of London. In 2005, Del Sasso and others reported a snout found by locals in 1975 and said that it was Spinosaurus aegypticus. But before we get to 2005, we have to go back to Spinosaurus in 1999. So, January 1999, Jennifer Smith, a doctoral candidate in Penn's Department of Earth and Environmental Science, was studying the geology of Egypt's Bahariya Oasis, which is about 180 to 190 miles from Cairo, for evidence of climate change and hominid and human habitation. She brought along her fellow doctoral student, Joshua Smith, who was also her fiancé, to accompany her for 5 weeks because she needed a man to be with her in a Muslim country, and her dissertation advisor couldn't make it that year. So Joshua Smith was a trained sedimentologist who'd always wanted to see Egypt, and actually the year before that, 2004, he and Matt Lamana tried to find a way to go. Lamana knew somebody who was working in the area, and then of course Stromer had found his fossils there. Josh, however, studied vertebrate paleontology, and he needed a reason to go to get his PhD advisor, Peter Dodson, to agree to the trip. Jen's research site passed through where Ernst Stromer had found Spinosaurus, so Josh negotiated, and they settled on 3 days of the 5-week trip for him to search for Stromer's lost dinosaurs. Of course, they had low expectations because there were no maps or known photographs of the sites, but there were notes about where he excavated and descriptions of landforms. He got really lucky, and he found a bone, 10 inches in diameter, 1 foot long, on his first morning while driving around, and then he found 20 accumulations of bones by the end of the first day. So he had found Jebel el-Dist, or Gebel el-Dist. It's a distinct landform, and it was actually Stromer's isolated cone-shaped hill, so they found a lot of bones, and Josh knew that he needed to go back for more excavating, but he needed funding. So once he was back in Philadelphia, Josh had drinks with R. Scott Winters, a PhD candidate in biology who was involved in the Explorers Club, which was founded in 1904 to promote field research and scientific exploration. Winters was also a partner in a film production company that made science and expedition-based documentaries. So he got a deal with $50,000 to fund the first field season between January and February of 2000 in exchange for the rights to make the documentary in association with Winters' company, Last Word Productions. They made the film, and it premiered in 2002. It's called The Lost Dinosaurs of Egypt. And with the funding, they had 21 people, and they excavated for 6 weeks. And the people included Josh Smith, Jen Smith, Peter Dodson, Matt Lamana, Kenneth Lacovera, Jason Poole, and volunteers, as well as the film crew. Jen Smith's PhD advisor, Bob Gagengak, had a network working as a geologist in Egypt, and they formed a partnership with Cairo Geological Museum and the Egyptian Geological Survey and Mining Authority for exclusive excavation rights in the Bahariya Oasis for 5 years. They agreed that half of the fossils they excavated would go to Philadelphia, and the other half would stay in Cairo. So this team arrived in Egypt January 11th, 2000, and they set up headquarters at El Beshmo Lodge, a cushy place they described because they could have hot showers almost every day and toilets that flushed. The rooms had tile floors and someone cooked them food. Jen Smith said in an article about it, quote, "Normally we work based out of a mud brick hut with a dirt floor and a pit toilet and there's no running water. That's what I'm used to."
It is cushy then.
Yeah. Their first few weeks out there were cold in the high 30s to low 40s degree Fahrenheit with strong winds. And then by the end of their trip, the temperatures went up to 85, 90 degrees. They also had 3 sandstorms in 2 weeks. And the team got food poisoning in between sandstorms before they found many fossils. They think they found some of Stromer's original sites. They said, quote, "We found what are very obviously excavation pits that had been filled in with sand blown in by the wind, in some cases burlap," end quote, which soaked in plaster was wrapped around fossils for protection during transport. And they even found in one case a, quote, "little scrap of newsprint with German writing on it," end quote, which sounds promising. They said that in the desert with the wind, sometimes you can see a bone, but then you dig and then there's nothing else. On January 27th, they found more bones, including a humerus that was 67 inches, and it was part of the sauropod that they ended up naming Paralotitan. By the end, they had excavated a quarter of the skeleton. Matt Lamana also found, half a mile from the sauropod site, non-dinosaur material including turtle shells, fish jaws, and other things that help show the environment. And they named that area John's birthday site in honor of his brother John, who was born January 27th. After their expedition, Josh Smith and Matt Lamana went to Munich to look for more evidence to help with future excavations. Luckily for them, Stromer's son, Wolfgang, had donated Ernst Stromer's archives to the Paleontological State Collection of Munich in 1995. So Smith and Lamana were able to go through Stromer's diaries. They found more than 100 glass plate negatives of Stromer's specimens, and one showed a partial skeleton of Spinosaurus mounted in a glass case in the museum. Before that, people didn't even realize the Spinosaurus had been mounted before it was destroyed. They also found evidence that Stromer was not a Nazi sympathizer, and they found 2 photographs of the holotype. Based on a photograph of the lower jaw and a photo of the mounted specimen, Smith said that the 1915 drawings were a little inaccurate. Oliver Rahout in 2003 said that Stromer's holotype was a chimera with vertebrae and neural spines from a Carcharodontosaurid similar to Acrocanthosaurus and a dentary from Baryonyx or Suchomimus, but not everyone agrees. Cosmos Studios and MPH Entertainment planned a sequel documentary before the first one aired. The Lost Dinosaurs of Egypt was the first one, and the team went for a second field season. The quarry known as John's birthday site had a lot of diversity in fossils. These fossils, though, were in hard sandstone, and that's hard to excavate. On one of their expeditions, Josh Smith and the team found one of Stromer's sites, which Markgraf had excavated. These were backfilled pits, maybe because whoever dug them ran out of time or money or both, and they wanted to preserve whatever was in there until they could return. It's possible this was Markgraf's last site. So now, fast forward to 2008. Nizar Ibrahim was on a fossil hunt expedition in Morocco. A man in a town near Arfoud showed him bones in a cardboard box, and Ibrahim arranged for them to go to the University of Hassan II in Casablanca. In 2014, Ibrahim went to Italy on a small doctoral student budget after Cristiano del Sasso contacted him about fossils that the museum had gotten in 2006. So he saw these bones in Milan and recognized a distinctive pattern that he remembered seeing in Morocco. The bones in Milan had been found in 1975, and they were originally thought to be the lower jaw of a crocodile, but they were part of a Spinosaurus snout. The fossils were collected by amateur fossil hunters and then sold to collectors on the private market. The teeth, vertebrae, and a partial skull found in North Africa post-Stromer. At the Natural History Museum in Milan, Cristiano del Sasso had gotten a large collection of bones from an Italian fossil trader and told that they're from Morocco, and they were likely spirited out illegally. They seemed to be from a single specimen. This included all the spines, the leg bones, foot bones, skull fragments, more fossils than Stromer's Spinosaurus. There were 60 bone fragments. Ibrahim moved the fossils to the University of Chicago, Paul Cyrano's lab, to be studied. It wasn't clear where exactly the bones were from or had originated from. So Ibrahim noticed that the spines had unusual lines, strange reddish lines. which was the first thing he noticed. But he also told us he noticed that the bones in Milan and the ones in Morocco were really similar in size, texture, color, and preservation. So the color, he said, was unusual. That has to do with the matrix at the site. He also said that he knew that associated dinosaur skeletons in the Kemkem are very rare. In the whole history of Kemkem scientific exploration, which started in the late 1940s, only 3 associated dinosaur skeletons were described: Rabacosaurus, Deltadromeus, and his Spinosaurus. Because of all these factors and remembering he'd seen the similar pattern in Morocco in 2008, he wondered if he could track down the fossil hunter to compare and learn where these fossils came from. But all he remembered of the man was tall, had a mustache, and wore a white tunic.
It's not the most unique characteristic to describe somebody in Morocco.
True. So Ibrahim flew back to Morocco and had some help, and he went village to village, shop to shop, chatting to locals for clues as to where this man might be. Morocco has vague export laws, and fossil diggers are allowed to trade and sell all common fossils, so dinosaur teeth, trilobites, but it's not legal to export rare fossils out of Morocco. These fossil diggers, they don't have special training, so sometimes the fossils will be damaged, and not everyone documents the rocks or where something comes from. It can also be a dangerous job. People have died breathing in too much dust, or sometimes structures will fall on them. However, they play a really important role. Paleontologists depend on these fossil diggers to find fossils, and then the fossil diggers depend on the income. On his second to last day of his trip, Ibrahim was at a cafe, sipping some tea, about to give up, and then a tall man in white walked past his table, and he happened to recognize the man's face, so he ran after him, and it was the man who had found those fossils, and he convinced him to show him where he'd found the bones. The man was worried about getting in trouble because the skeleton was illegally abroad, so he does remain unidentified. So they ended up driving an hour off-road, and then they trekked up a mountain for 30 minutes to a nondescript hole in the hillside. And this dig site had fragments of bones and teeth, most likely Spinosaurus. The man said that it took 2 people digging 2 months to get the skeleton out, and they sold it to the Italian fossil dealer for $14,000 US. This site gave a lot of information about the environment of Spinosaurus. Paul Serino, Del Sasso, and colleagues from the UK and Milan went to excavate and then to characterize the rock and landscape to see when and how Spinosaurus lived. And they found fossils with the same unusual patterns, so they confirmed it all came from the same specimen. They also found sea urchins and mollusks, marine animals, and shellfish. Not many herbivores were found in the area, but there were a lot of different carnivores and predators. So, back to Stromer's riddle. Sawfish, lungfish, and coelacanths are in the fossil record, and they could have fed Spinosaurus. The idea was that Spinosaurs were built to catch fish. And because they could eat fish, they wouldn't be competing with other predators in the area, and that's how the area could sustain the carnivores. So after the expedition, Ibrahim and the team CT scanned all the bones and they made a 3D model, and Tyler Keller assembled them into a virtual Spinosaurus. They added some missing parts based on Stromer's figures and drawings, as well as scans of Suchomimus for the skull, for the brain case, for example. So they started with Spinosaurus at 40% complete, then they went to 60% complete with scaling and other dinosaur parts and isolated bones. There's a lot of controversy on Ibrahim's 2014 paper on Spinosaurus, and then of course, as we've talked about, Ibrahim also published about the tail in 2020, so diving into that. In 1934, Stromer described specimens, including long bones, vertebrae, some teeth, that he thought was a single taxon, and he called that Spinosaurus B. But he said parts of an ilium and leg bones were too small to be part of the same individual as the rest of the material. They found teeth, vertebrae, gastralia on one side, and the long hindlimb bones on the other side that belong together, but this has been questioned, and the material is lost from World War II. Stromer thought that this was a new species of Spinosaurus, so not Spinosaurus aegypticus, but he didn't like naming dinosaurs based on fragments. He wrote, quote, "I refuse to participate in the abuse of coining new genus and species name on the basis of such isolated and totally incomplete remains, which then, due to the, for paleontology, completely inadequate priority rules of nomenclature and their senseless pedantic application, will have to be used for further nomenclatorial acts," end quote.
I love that. He's spinning in his grave, though, based on some of these recent dinosaurs that are named.
Right. But anyway, that's why he called this Spinosaurus B. Stromer also described another specimen in 1934, but briefly. No illustrations or photographs have been found. That included 3 cervical vertebral centra, 2 half neural arches, the midsection of an elongate dorsal neural spine, 2 ribs, and possible distal fibula. And it was described as having similarities to Spinosaurus B and Spinosaurus aegypticus, but there's not enough information on this now to study.
Because all those fossils were destroyed.
Yeah, and there's no illustrations or photographs. The Kemkem region of southeastern Morocco has many predatory dinosaurs, including Spinosauridae, and Dale Russell, who named Spinosaurus moroccanus, also named Sigilmosaurus brevicolus in 1996, which has been interpreted as Carcharodontosaurus saharicus, then Spinosaurus moroccanus, then Spinosaurus aegypticus. Russell also later proposed that Spinosaurus B was Sigilmosaurus because he said they were nearly identical to bones from the early late Cretaceous sediments in Morocco. Russell then described Spinosaurus moroccanus in 1996 based on the length of the neck vertebrae and said that it was longer than the ones found with Spinosaurus aegypticus. Some scientists think that this is due to individual variation, but the holotype of Spinosaurus was destroyed, so they couldn't compare it directly with the new species. But some people think that Spinosaurus moroccanus is a nomen dubium or a junior synonym of Spinosaurus aegypticus. In 2014, Ibrahim and others designated the neotype of Spinosaurus aegypticus and said that Sigilmosaurus and Spinosaurus B were Spinosaurus aegypticus and that Spinosaurus moroccanus was a nomen dubium. In 2015, Evers and others said that Sigilmosaurus was a distinct genus, and that was supported in 2018 by Arden and others. And they said it was a close relative of Spinosaurus. And they said that there was more than one Spinosaurid taxon. They said that the proportions of the hind limbs were shorter than previous reconstructions. Based on Ibrahim's description, Spinosaurus had shorter hind limbs than previously thought, and they also found Sigilmosaurus had shorter neural spines than Spinosaurus. Since the Spinosaurus aegypticus neotype came from different museums and then parts were collected at different times, some scientists suggested that it wasn't made clear which fossils came from where, or that there was evidence that the material all came from the same place and was from the same individual, so it was hard to make the neotype. So again, controversy. Lots of debate on all aspects of Spinosaurus. Then Ibrahim and others published their 2020 paper on Spinosaurus. Ibrahim returned between 2015 and 2019 to that site and found, quote, new fragments of the cranium and mandibles, several previously missing bones of the left and right pes, and an 80% complete tail by length, which all became part of the proposed neotype. They estimated that the Spinosaurus neotype was at least 15 years old based on 10 lags in the fibula, and then they estimated there were 5 more that were probably there before. The ribs had a similar number of lags. The spine, however, had fewer, so it's possible that the sail grew taller as it aged. Ibrahim has said that he's hoping this might help get a Moroccan National Museum of Natural History built. And museums are really great at getting local support for paleontology. As Garrett mentioned earlier in the show, if you can remember that far back, you can see Spinosaurus in Jurassic Park 3, where it has the more typical theropod skull, because that's before we found all this new material. Jack Horner said, quote, if we base the ferocious factor on the length of the animal, there was nothing that ever lived on this planet that could match this creature, Spinosaurus. Also, my hypothesis is that T-Rex was actually a scavenger rather than a killer. Spinosaurus was really the predatory animal, end quote.
Much disputed and controversial.
Yes.
We've spoken to him since that quote, and he no longer contends that T-Rex was a scavenger.
Yes, yeah, he's since retracted it. But again, we're always finding new evidence, new fossils, and learning new things. You can also see Spinosaurus on postage stamps from Angola, the Gambia, and Tanzania. For those of you who listen to our Dinosaur of the Day segment and you like it, please consider becoming a patron. We take new Dinosaur of the Day requests from our patrons and offer a bunch of other perks as well. So check out our page at patreon.com/iknowdino or click the link on the left.